zoom in a little bit here, you can actually see the line of code. There's a line showing me which line of code caused the error, and I can see the exact error message that occurred, 0 division error. That's really useful. We're going to take a little note of that. That's useful information. And there's a description of the error. There was a float division by 0, which is actually a really good description because I had a floating number and I tried to divide it by 0, and that's causing the error. So do take a look at that information because that is really useful. When you're trying to write your error handling, you're going to want to know that information. Okay, so I have a calculator program. I now have an error that's running.
Yep.
So there's our scenario. We have our division by 0.
Yep.
So which line of code generated the error message? Christopher?
1, 2, 3, 4, 5. Well, in this screen, error 5, line 5.
That's right. And in this case here, it's the line where I'm actually doing the division that's caused the actual error. It's important to know which line of code generated the error because that's going to determine where you're adding the error handling code. You could just put error handling code and say, if an error occurs anywhere in the program, do the following. But in this case, you might get different errors at different places. So it's actually better to say, hey, if this line of code gets an error, it might be divide by 0. If I have a line of code that opens a file, well, I'm expecting errors because it tried to open the file. So I might want to handle different types of errors differently depending where they occur and what types of errors they are. So it's generally better to try and put the error handling around the chunk of code you think could cause a problem.
Yep.
So what we're going to do is we're going to add something called a try except.
Actually, you know, it was funny. I was hoping to time it perfectly, and I missed by that much. Somebody had actually posted it into the chat window maybe about a minute and a half ago saying, hey, is there a try-catch like C#? So there you have it.
For those of you who have used C# and used try-catch, we have try except in Python. The only thing is if you use C#, you're going to keep typing catch instead of except by accident.
Exactly.
The syntax is you use the word try and your colon, and you hopefully by now you're starting to get used to the indenting. So the code that might cause the error, you put inside the try. So here's the code which I think may generate the error. And what I do is I write an except. So I say try running this code. And the reason it's called except is because we often call errors exceptions.
Yep.
So if an exception occurs, then I want to go do this instead.
The way that I always like to analogize this is it would be like if I turned to Susan and I said, hey Susan, can you do me a favor? Can you run down to the store and get me a
Need a coffee?
bag of chips? Yeah, get me a coffee. Yeah, go down and get me a coffee. And so I want to make sure that she also understands what to do if something goes wrong. But what I don't want to do is I don't want to say, okay Susan, go get into your car. And then if something goes wrong with getting into the car, I want you to do this. All right, now I want you to start the car and I want you to drive down. And if while driving something, because just like it would be annoying for somebody to explain all of that to you, it's annoying trying to program. So what I really just want to do is I just want to say, hey Susan, go down to Starbucks, get me a coffee, hopefully a dark raw roast.
Yep.
Then, if something goes wrong, get me an iced tea instead. So you'll notice that what I did is I just gave her everything of, hey, this is what I want you to do, assuming success. And then if something goes wrong, do something else. You know, basically let me know. And so if we take another look at the code, that's exactly the way the code is written. Is you'll notice
try to do this.
Yeah, try to do this. No error handling inside the try block. We're just assuming success. And if something goes wrong,
then we're going to say, so we're saying if. So if an error occurs anywhere in this code, it will jump to the except and execute the whole code here. So the only time you're going to see that message, print, I am sorry, something went wrong, is if an error occurs in the code you have in your try. So let me go add that to my code. So let's try that here and see it in action. And I'll actually, so we're going to say try to calculate a result. And you know, assuming everything goes well, after we get a result, I want to print it. So I'm going to leave that print in there as well, in this case. And then I'm going to say, now, in the event there is an exception, I'm just going to print, I am sorry, something went
And then as Susan is typing all this out, I
Wrong.
just want to mention real quick, somebody asked in the chat window about the possibility of throwing your own exception.
You can absolutely do that.
Yeah, and you can do that. Yeah, there's a raise function that you can go ahead and call to raise a brand new exception. And that's something you might decide to throw into your functions and so forth. For right now, we're just kind of focused in on error handling. But just to answer the question, quite simply, yes, you can. It's the raise function.
Yeah,
Yep.
and you would use a raise function for those of you who are sort of going, why would I want to make my own errors?
Yeah.
It would be when you have business rules.
Yeah.
So if you have certain business rules that if somebody's trying to deposit money to a bank account and they try to deposit minus $1,000,
Yep. That's a problem.
then you say, wait a second, if I'm depositing minus $1,000, is that or even better, I'm withdrawing minus $1,000, but I'm giving myself $1,000?
Hey, I like that.
Neat
Yeah.
trick. Again, errors I'd like to write into your code. So that's something where you might have a business rule that says when somebody tries to deposit money, it must be the value must be greater than 0. And if the value is greater than 0 or not greater than 0, you might actually want to throw your own error to say, yo, hey, somebody's trying to deposit a negative amount. This doesn't make sense.
Yep.
So you use the raise command to raise your own errors.
Yep. And somebody else asked, is there a methodology on what to do with an exception? And a lot of times when somebody says exception handling, they make it sound very grandiose, that you could detect what the problem is and magically fix it. And yeah,
If the file's not there, the file's not there.
Exactly. And, sometimes maybe you could, execute some code and pull from a database and recreate it or something like that. But those times are so extremely rare that really all that you're typically doing is you're just simply going to write out to a file maybe, print a friendly error message to the user, and that's really it. Now, exactly when to catch errors and so forth, that's a much bigger conversation. But to kind of simplify it, go with the core part of it, typically when you catch an exception, what you're going to be doing is just, exiting gracefully and maybe logging it out to a file.
Yeah, giving a nice error message so people have an idea that it's not them.
Exactly.
If you can tell someone...
It's not you, it's me.
It's not you, it's me. Yeah. The one situation where sometimes you can fix it is if a user entered something in the wrong format.
Right, yeah.
Sometimes you have the ability to say, hey, you need to give me the date as day, month, year.
Yep.
Please enter that again. And then you go back to the code. You might have a loop or something or a function that you call to say, prompt them again for that date value. So that's
Exactly.
the one
Yep.
scenario that's the most correctable in your code.
Yep.
So if your problem is a user entered something wrong, you
Yep.
could write code that says go let them try again, to try and enter it again. That's probably the one most correctable error handling scenario. But most of the time you're just going to exit and say, sorry, I can't do this because this happened.
Yep, exactly.
Yeah. All right, so what I have in this code, what we have, just zoom in a little bit there, is so we've accepted 2 numbers. We try and do our division, so we're trying to do our division. We assume everything goes well. If something does go wrong, if there's an exception, another word for error, then I'm going to print a message saying, sorry, something went wrong. And
Yep.
if I run the code and I enter 10 divided by 2, well, everything goes great.
Yay!
Yahoo! And if, on the other hand, I try 10 divided by 0, I hit the NE key a little too quick there. Sorry about that.
Yeah.
0. And you can see the error message comes back and say, I'm sorry, something went wrong.
Yep.
So it's actually kind of neat if we put some, put a debugger on here and I run this again. So we ask somebody to enter the first number, right? And then the second, so I enter the number 10. And then it says, then I'm about to execute the line and get the second number. So I execute that line of code and I'm prompted to enter the second number. I enter 0. And now you can see it's ready to go into the try statement.
Yep.
So it tries to calculate the result. And when I hit the step into,
Yep.
it's not going to go to the print statement.
No, and this is very important.
Yeah, it's not going to the print statement because there's an error. It immediately jumps to the accept and prints out the error message. So when an error occurs inside your try, whatever line generates the error, it will immediately jump to the accept statement. It will not continue executing the code inside the try.
Yep.
All right. Now, the other thing is also important to recognize is the code inside the accept will only execute if there's an error.
Right.
If there's no error, the code that you put in the accept never runs.
Yeah, that if you remember back to when Susan ran that a couple seconds ago, when she did 10 and I think 2, it just simply printed out 5.0, exactly what we were expecting, and it didn't print out, sorry, something went wrong, because, well...
Nothing went wrong.
Exactly.
Exactly. So
simple logic.
now, one of the things though is sometimes you might know something could go wrong, but you're not exactly sure what the error message is that's going wrong. So you might just want to say, tell the user something went wrong, but something a little more useful than, hey, something went wrong. And then the user's calling up support and going, what's the problem? I was running the code and I got a message saying, I'm sorry, something went wrong. You do that and your support team is going to laugh hysterically.
Yep.
Because the fact is, if you are the coder who, like the support team is usually people who fix code. And if you go to me and say, hey, Susan, I got a message that says something went wrong, how do I know what went wrong? Which program was running? What type of error message was it? Give me a hint as to what went wrong so I can try and fix it.
Yep.
So one of the neat things you can do is there is a variable, actually it's part of a module called sys, and it has a function called exc_info. Not very intuitive, but really useful. And if you ask for, this will contain the complete error message. And the complete error message is actually a massive list with all kinds of details about where the error occurred, all kinds of stuff. You might actually take that information in a big program and write it to a file.
Yep.
So if a support team could look at it later to get the full information. But you wouldn't want to show all of that to a user if they would just sort of be overwhelmed by it.
Right.
So usually we just take the first part of that list, the first value in that list is the message, which is divide by zero error or could not locate file. Something that a user might actually understand or might have meaning if they call support and say, hey, I got a message saying divide by zero error or could not locate file. That's something the support team may actually be able to act on and be able to fix. Or if a coder can actually do something with that and hopefully try and fix it or find out, oh, wait, we forgot to copy the file over. So what I'm going to do now is I'm just going to go back to my code, and instead of displaying a really generic message, which isn't that helpful, I'm sorry, something went wrong, I'm going to actually declare a variable called error, which returns system.out. And I just realized I'm going to need to import the sys module before I can do this, because I am accessing functionality of the sys module.
And while you're doing that real quick, somebody had asked, could you simply test to see if it was 0, and if it was, then prompt the user for a different number?
And that would be even better.
Yeah, and you absolutely could, and that would be, a concept called validation. But divide by 0 is just such a great little example to do with the demo. So that's kind of why we're going that direction.
But you know what? So. But you make a really good point. If you can stop the error from happening in the first place, that's even better.
Yep, absolutely.
Sometimes we'll write code that will look for a file before we try and read it. So we can actually say, I just looked for the file, it's not there. And we come back and say that file could not be located.
Yep. And then one other question that was in there, which is worth highlighting, is somebody asked about finally.
Oh, yep.
And there is a finally as well. And finally, just kind of real quickly, this is a block of code that will always run. So if maybe you needed to close off the connection to the database, you need to do that if everything went correctly or if things failed. So you could do that inside of a finally as well.
Yeah. Yep. Maybe I'll try adding it in a finally a little later, just so you can sort of see how that works. And I'll run the code and you can see how it executes. So hopefully I got the syntax right. I'm just going to double check the syntax of exc_info bracket. Yes, I think I got it right. And then I'm going to say, then I can just print the error message to the screen itself. So what I'm doing now is I'm just asking if an error does occur, then I'm just asking the system to tell me what the error message was. And now I can tell the user that message. So now when I enter 10 and I enter 0, I can actually see there's a class 0 division error. Except the user, this isn't going to be that meaningful for them, but if they're calling support and saying, hey, I had this problem, that's going to help the support team figure out why they're getting this error message in the code and hopefully fix the problem so the user can get their job done. Yep. And that's actually really important. And yeah, just to talk about the finally, because somebody was asking about it, because in C# we have this concept as well. Finally, print, I always like to do this, I will always run. So you can actually have a line of code that always executes, or multiple lines of code that always execute. So I'm going to go back to putting in I'm going to put the debugger in again. Okay. And when I specify a value of 10 and a value of 2, you can see I'm in the try statement. I go to calculate the result. You can see by the yellow arrow the next line that's going to execute. Then I go print the result because everything's going fine. And then watch how the yellow arrow is going to jump down to the finally. So over here, hang on, what's the shortcut key for that? That is F11. All right, so I can zoom in a little over here. All right, so I'm going to zoom in a little. And when I hit the F11 key, it jumps right away to the finally.
Yep.
So if everything goes well and there's no error messages, then we go and we do the code in the try, then we execute the code in the finally.
Yep.
And the message is displayed on the screen. I get my result. I get the 5.0 and the message I will always run.
Exactly.
And if I have an error, so let's try exactly the same thing, but this time I'm going to enter 10 and 0, so I get a mistake.
Yep.
And once again, I am going to go to my code here. I'm going to zoom in a little. So I'm at the line with the yellow arrow is the next line that's going to be executed. It tries to calculate a result. Because it's an error, it's going to jump right away to the accept.
Yep.
It executes the logic in the accept, and then it goes to the finally.
Yep, so the finally always runs, which is a big difference between doing that and just simply putting the call at the end of the try block. Because remember that the moment that the exception is thrown, it stops going down in the try block. That one of my early C# trainers taught me this, is that you're basically going this way in code rather than this way. That you're now going up in code, that it's just bombing out of that try block, and then it's just going to go straight for the accept block here.
Yes, so that's particularly important. As you pointed out, Christopher, the things like if you connect to a database, you need to close your database connection, or if you're opening a file and you need to close the file, regardless of you have an error processing the data in the file, you always want to close the file. So something like a closed file might go in a finally, or a closed database connection.
Exactly.
Those are most common scenarios you would encounter.
Exactly.
Yeah. Other than that, for divide by 0, I probably wouldn't bother.
Exactly.
Bothering with finallys anyway. So sys.exe info, useful way of accessing error messages, and we just saw the finally clause.
Exactly.
Now, if you know exactly which error is going to occur, it is possible to say, if that error happens, here's what I want to do. And that can be useful. So you can say, if I can't find the file, tell the user I couldn't find the file. If something else weird happens, like maybe permission problems or something, then I'm going to display a different error message.
Yep.
So the way you do that is after the word accept, you actually specify the name of the error. Now, how on earth do I know what the name of the error is always the big question.
That's a very good question.
Well, you remember on the previous slide, I showed you sys.exe_info?
Yep.
Guess what that returns? The name of the error. So I actually will often use sys.exe info as a programmer to find out the error. I don't often display it to the user. It's a trick I use to find out the error. And then I know the name of the error to trap.
Yep.
So that I can say, if that error occurs, this is the message I want to display. I'm going to tell them, hey, you're trying to divide by 0? The answer is infinity.
Yep. And beyond.
And beyond, exactly. So what I can do now is I can say accept 0 division error. I'm just going to double check on that. 0 division error. Yep, got that right. And then instead of doing this sort of generic error message, I'm going to display a whoops, didn't mean to do that. I'm going to print a message that says the answer is infinity. And think of how nice that is as a user experience. It's not appearing as an error at all. I'm saying,
Right.
yeah, you want to divide by 0? I'll tell you the answer to dividing by 0. You try dividing 10 by 0? Whoops, I've still got the breakpoint. Get rid of that. We don't need to step through this code. Try this again. From beginning. 10 divided by 0? Sure. The answer is infinity.
Yep.
On the other hand, if you ask me what is 10 divided by 2, well, it's 5. So this makes it to the user, but it doesn't even appear as an error. And that's a really nice way to do things, if the user doesn't even see it that way. What you may want to do is, what I recommend when I'm doing error handling, is I try to handle as many specific errors as I think, the types of errors, I can predict certain errors. I might try to open a file and the file's not there. I try to do a division, I might end up dividing by 0. So if there's errors I can predict, I like to specify what to do for those specific errors.
Absolutely.
But there are errors I might never think of. So but I also include a generic accept, and this basically will execute if any, so when my code is running, it will try and calculate the result. If it gets a divide by 0 error, it's going to jump to accept 0 division error.
Yep.
And it will execute this code and exit.
Yep.
If it gets some other number, like some sort of data conversion error, or the number's too large to store inside a float variable or something like that, it's going to say, oh, I've got an exception, jump to the accept. Is it a 0 division error? No. Is it something else? Yes.
Yeah.
And it will go in order. So it'll check, it'll go, is it this error? Okay, then I'm going to do this. Is it this error? No, I'll do this. Is it this error? No, I'll do this. And then you have the, if it's anything else, here's what I want you to do.
Yeah. And, one other thing to kind of highlight, Susan mentioned, focusing in on the errors that you're expecting. And it is also worth thinking about if you are expecting something might go wrong, maybe test for it. We talked earlier about, 0, and just check for it rather than doing the exception handling. The other thing that I would mention is, again, going back to the module that we had prior to this about doing functions, is that a lot of this or all of this could wind up inside of a function. So rather than having all of that code right there, instead we could just put together a function that does that behavior and just gives me the answer back. Yeah.
Yep, exactly. It's a nice way of doing it.
Yeah.
So we've shown how to trap errors. We showed you the finally clause.
Yep.
The other thing that's good to be aware of is if you do put code after your try except as well, that code would also execute all the time.
Yep.
So if you have code that's not indented, right, because only the indented code is part of your except error handling, well, what's going to happen if I run this code is it's going to try to do this code. If everything goes well, it'll chug along, and then it's going to jump to the first line of code after my try statement. So it's almost the same as putting it in a finally.
Right.
There's really not a lot to choose between making a finally statement that does that and just putting it after your full try except. Except some people like the format of the finally.
Some people like the format, and the other big thing is, somebody asked earlier about raise. So, and I'm going to say this, and I'm going to try very hard not to get too advanced.
Actually, I'm going to, you know what? Give me 2 seconds, because I'm actually going to show, I'm going to kick someone out in a second of the code. So I'm going to show how do I not execute this line of code. Will that lead in?
Sure. Go for it.
Because I think I know where you're going. So let me show one more thing, and then I think I'll let you run with that.
Go for it.
Okay. So it said, so in this situation, with this code I have on the screen right now, you could put that print statement in a finally, or the way I have it on the screen, and it really isn't going to make a difference with the code I have on the screen. Would you agree with that one, Christopher? For the code I have here.
Right now, yeah.
Yeah, it really wouldn't matter for this exact code. It would not matter if I used a finally statement or I put the print message here. I'm always going to see the print message. This message always displays. Now, sometimes, though, when we're executing code, we do want to actually say, oh, wait, if that error occurs, don't keep going. Stop. So there is a function sys.exit, which you can use to say, get out. Or you can also, some people ask about raising exceptions. If you raise an exception, that'll also cause it to go, get out.
And that was actually the point that I was about to make, was about raising the exception.
Yes. Yep. So if you either call sysexit, that's just a way of saying exit now. Or if you raise your own exception, which hasn't been handled, because if you raise an exception inside your except block, you haven't written code to handle the exception in the except block.
Right.
So that causes the code to go, I'm getting out. In that situation, this code, if you get the zero division error, when it hits sysexit, it exits, and this line of code will never execute. Right. Now, what if I had a finally, Christopher?
Finally is guaranteed to run.
Exactly. So that's what the difference is between finally and having this line of code.
Yeah, and actually a lot of people have asked that. So it's good to highlight that the finally is guaranteed to run. And it's perfect, and again, we've been keeping our demonstration simple because we're trying to focus in on the syntax, but if you needed to close a file or close a connection, that's where finally comes into play.
Yeah, even if you use something like sys.exit, the finally will always run.
That's it.
So that's the difference between this syntax we have on the slide versus putting that print statement into a finally. The other thing you could do, this is just, I wanted to show an alternative way of handling an error or sort of exiting, not executing certain code if an error had been raised. The other thing we'll sometimes do is we'll create a Boolean variable and we'll say, try running this code. And if an error occurs, we set a Boolean variable to true. And if it doesn't occur, we set everything went well, then we set the flag to false. And then after we've done all our code, we say, well, if the error flag is true, then continue executing. So, I mean, you can just write logic that basically says, if an error occurred, do this. If an error didn't occur, do this. And I'm just using a Boolean variable, setting it to true or false based on whether or not the error occurred. So this is just creative coding. Lots of different ways to tackle problems. If you look online, you'll find lots of other examples of different ways to handle exiting code as well. If you actually look at the code here, though, there's other code here that could cause an error. We have code here. We've been handling the error that can occur when you divide by 0. But Christopher, can you see anything else in this code that might actually crash at runtime?
Oh, yeah, if somebody entered in Bob, a few people had pointed that out. Yeah. Or Wibble.
Yes, exactly. If somebody enters, when I ask somebody to enter a number and then I convert it to a float, if they entered letters or something that's not a valid number, then when I try and convert that to a float, which is a number that has decimal places, that code would crash too. So you might need to try except around first and second number. And I actually might do this separately. I might have one try except around the data conversion that handles the, hey, you entered non-numbers. And then if they do that, I say, well, try again. Whereas the divide by 0, I would handle differently. So you might end up with 2 try excepts in the same code.
And not only that, but forgive me for kind of beating on this horse a little bit more, but again, you could put that into a function. So I could create a function that says get number. And inside of that I've got that try catch, and I'm just going to keep looping until you give me a number. Once you finally give me a number, then I'll go ahead and I'll pass that back. So rather than having that try catch twice, we just put that off into a function and then call that function. Yeah.
It'd be a lot tidier, a lot easier to read.
Exactly.
When you start having multiple try catches in your code, it can get kind of clunky. So you're looking at functions initially going, I don't know if I'm ever going to bother with functions. This is the kind of thing where when you get used to it, you're going to discover it's going to be a lot tidier. And easier to follow.
We need to remember to say try except rather than try catch.
Oh yeah, I'm sorry we've been saying it. Our apologies. Yes, we both have spent more time coding C# than Python. So,
exactly.
So there's some habits. By the way, the further you get into coding, the more languages you will find yourself learning and the more you will mix them all up. You don't make less typing mistakes the more you code, you make more because you start using the wrong syntax.
Look at the number of colons that we've missed on if statements and other blocks.
Exactly. All right. So as I said, we've got a lot of different situations that might raise errors in our code. You might be converting one data type to another. You might be opening a file, doing a mathematical calculation, trying to access a value in a list if it doesn't exist. All of these sort of things could raise errors in your code. How are you going to have any idea what errors are going to be raised? This is always a challenge. When I was coding, this is something I always sort of got stumped on. Number one, you can test it yourself. And when you get an error, use that sys.exe info function to get the name of the error. There is also, though, and there's a nice link here, a list of fairly standard Python errors. So this is a list of about 20 errors that you may want to catch, and it explains when they're raised. So that's something that's worth taking a look at after you're writing code to go say, oh, that actually could happen in my code. I should probably handle that error. So there is a fairly standard list you can use. The most important thing to do, though, is you have to test. That is really your best thing. First of all, so you get your code done, your first goal, your first test, is just see if everything works normally. Don't start by testing error handling. Just see if your code basically works. We actually have an expression for this. We call it the happy path. Make sure the happy path works. Because it makes you happy. You're like, yay, my code works. Before you deal with all the error handlings and the weird what-if scenarios. Start with, can you just basically get the code to work? Does 10 divided by 2 work? Yes. Okay, now that I've got that working, now let me try maybe entering incorrect values. That's a really common thing, because that's what's the likely scenario? User types in the wrong thing. So try typing in letters instead of numbers. Try 0. 0 does weird things.
And try the fringe cases. And this goes back to something that Susan really highlighted yesterday is, if you're doing a less than 1,000, test 1,000. Go in and test the fringe cases.
Yeah, exactly. Enter a value in the wrong format. Enter spaces. So try some things
Try to break it.
Yeah, well, but not too hard. Try to enter things that you think a user might do. They might forget to enter a value at all and just hit the enter key. See what happens. So try sort of typical things you think a user might do. That's the second thing to test. Once you're handling that, then start going into what else could go wrong. Start using your brain. Go, what if the file wasn't there? So then you try things like, what if the file is missing? And then you get into, now just try anything you could think of that might break it. If you've got the time, try negative numbers. Try entering 99999999999.9999999 and just see what happens. But that's if you've got time. A lot of times, I'll be honest, we don't always get to that level of testing.
And not only that, I'd be remiss if I didn't at least mention it. And again, this is an advanced topic, but there is a concept called test-driven development, where you actually write the tests before you write the code.
Yeah.
And one nice thing about that is when you start getting into that, you can automate a lot of that. Remember, Python, one of the biggest reasons that people use Python is for automation. Well, you could automate a lot of that. Or just start feeding in random numbers and things like that to test it and go about it that way. So just to mention it, put it out there, test-driven development and Python.
Yeah.
So I'm done.
Yep, absolutely. Which is basically the concept is you write a program that calls your program and passes it the values you would use to test it.
Exactly.
That's what it is really when it comes down to it. It's a program that calls a program
Yep.
with the values you would use for testing.
Yep.
So that when you need to rerun, you make a change, you want to retest it, you want to make a change, you want to retest it, and you want to make a change and retest it.
Yeah.
You just call a program that calls your program with the right test values.
Yep.
That's the idea of automated testing. And when you get to